Hey everybody, let's sing the Studer song. Whoop pop pop, pop pop. Anyway, this here is a Studer A810 tape recorder. Yeah, an analog tape recorder. Dig it, man, dig it. You want your band to sound like Three Dog Night? Or how about the Grassroots? Bobby Sherman, there you go. Yeah, you need one of these. There's a reason why they don't have these anymore, and we're going to get into that in a second. What we have to do is check the alignment on this machine. It's going somewhere. To a museum? I don't know. Someplace. One of the problems with analog tape is it's labor intensive. Every one of these points on the tape transport has to be absolutely positively perfect. And this machine, as you can tell, is far from perfect. Let me show you. This machine was used at a radio station, a radio studio. You can tell because it has a moron ring. When the reels are all warped, a moron continues to use them, and that's how you get those. Recording studio machines never have that on there. It also has some scrapes down here from a razor blade, and the editing block, editol block, has scrapes all over it. And it's just generally dirty. It looks like it went through World War II, you know, or the Vietnam War. Anyway, our tape is out. This is a magnetic reference laboratory. Catalog number, what is it? It's a catalog number, you can't see it there. Catalog number 243213462-126. 15 IPS alignment tape. For use with this, the Sound Technology 1510A tape recorder analyzer. I once had a vice president of engineering tell me that this was voodoo. It's wrong. This can't be right. Well, that same guy blew up an AM transmitter. He would rather use one of those. Well, you can use one of those. There's nothing wrong with it. It just takes forever to do it with that. This thing, you can do it in about 5 seconds. Anyway, let me get off my high horse and stop being confrontational. The first thing we have to do is thread the alignment tape. Now, we've previously gone through the machine to make sure that it's not magnetized, the tape heads are clean, and all of the tape path components are smoothly running and smoothly lubricated. And oh yeah, we cleaned the pinch roller. The Studer has a neoprene pinch roller. You don't clean this with alcohol. You clean it with Windex. Yep. Clean it with alcohol, it gets all gummy, and it gets gummy real fast. And this particular roller is a smaller size than most. It's harder to find, and you can still buy it from Studer. They're about 80 bucks a piece. Actually, it's Audio House now. It's not Studer. Anyway, we have to make sure the tape path is nice and smooth and parallel, and then it works. Okay. Anyway, we've done all that. In fact, we've already done the 7.5 IPS alignment on this. Now we're going to do the 15. You can watch me do that. 15 IPS, here we go.
MRL calibration tape, NAB equalization at 200 nanowebers per meter, fringing compensated.
Yeah. Let's see. That's a little high. That's a little high. What's our analyzer say? We go AC volts, input. Ooh, let's see, 4.2, 4.2. That's damn close. I'm not touching it. That's close. 1/10 of a dB. What's 1/10 of a dB? You're never going to notice that. All right. So, if we did have to change it, on the Studer, you go over here to change it. You use this marvelous little keyboard and you go track 1, reproduce level, and you go da-da-da-da-da to raise it and da-da-da to lower it. And then track 2. Da-da-da-da-da. I'll lower it a little bit. Da-da-da-da. There. Okay. Store. Okay. We also have buttons for our treble repro and our bass repro. Yeah. Alrighty, that is a 20 kilohertz, actually 16 kilohertz calibration tone. And look at it, it's right on the money. 16 kilohertz, I can't even hear that. Most people can't even hear that. This damn machine is flat. You know, it's flat. I know pretty darn good. I am very Studer. I make the finest tape recorders in the world. They are better than Scully, they are better than Ampex, and they are better than Otari. Yes, indeed. That's really Studer. By the way, folks, trivia question. Where is Studer? Where is Studer? It's not in Germany. No, no, no. It's in Switzerland. See, right there. Studer, Regensdorf, Zurich, Ostrastrasse 30, whatever 30 is, Teintigen. Hey, what time is it, folks? It's time to set the azimuth. Yeah. This noise is the noise that this machine uses to check azimuth. So we go that way. That looks pretty darn good, see? Any error would show up as a little bar. Now you notice it's wavering back and forth. That's because this is a worn tape machine. It's probably had 1,000,000 miles of tape run across those heads. And of course, since it's got moron rings on it, you know darn well it's had a lot of abuse. That's pretty darn good. Passes the azimuth test with flying colors. Now it's time to do our frequency response. We go to the frequency response department right there. See? Frequency response. And we see this little graph. And we'll have the right channel here and the left channel here. Gotta put this on 0. There we go. So, let's start. We hit input. Fire in the hole! There we go. See? And we hear this. It sweeps down all the frequencies. So looking at that meter, it's pretty good. Well, a little bit of roll off there, but that's the low frequencies. And we go over to our graph. There's the left channel right there. And there's the right channel. 2 decibels per division. That's pretty darn flat, folks. Oh, no, no, no. Ooh, look at that low frequency. Bumpa, bumpa, bumpa. We gotta get rid of that. Okay, let's try that again. Make a fine adjustment. There's our right channel. Yeah, look at that. That's pretty darn flat. Even down at 50 even down at 50 hertz, it's still within spec. Let's see how the left channel goes now. Tame that EQ down a little bit. Oh yeah. Yeah, much better. Much, much better. Okay, one last check here, and it should be pretty darn good. Let's see. This is 20 kilohertz, 1,150 hertz. That's, you know, flat as a ruler, flat as a pancake. This one's got a little bit of an exception here on the left channel. That's not bad at all. Look at that. That is high fidelity. At least as far as frequency response goes, that's high fidelity. Output level is exactly where it should be. +4 dBm. Right now that's our infinite noise there at meg 60, meg 70. It's a quiet machine. Here we go. There we go. That's pretty darn close. Let's see. 4.3, 4.0. Alright. I'll buy it. So you've seen the playback alignment at 15 IPS of a Studer A810. Now, this is a very good tape machine. In fact, if you look at those tape heads, you'll see a noticeable groove in them. You know, a worn Studer machine will still perform. In fact, it outperforms many perfect, pristine makes of other machines. This Studer is not even regarded as Studer's best machine. That's a judgment call, but many people regard the A80 as a better machine. I would agree. But in any case, this machine blows the doors off of an Atari MTR-10. Even in its present shape, with the heads all worn out, and with some mechanical irregularities, this machine will record much, much better sound than an Atari MTR-10 with brand new heads on it. Of course, we didn't get into record alignment. I don't have time on this recorder to make a record alignment thing, but if somebody wants to, just email me and I'll go through record alignment too. It's a great machine. We're all ready to record the symphony. Mr. Prokofiev, let's go.